Welcome to ISL Enabled Virtual Lab of CSIR.
Heat transfer. Heat is the energy in transit from one system to the another or from one part of the system to other arising due to temperature difference. There are three different modes of heat transfer: conduction, convection, and radiation. Conduction is the mechanism of transfer of heat between two adjacent parts of a body because of their temperature difference. To perform the experiment on conduction, we require a flat stainless steel rod, 4 nails, a candle, a stand, a lighter. First we fix 4 nails on the flat stainless steel sheet by putting hot wax on it. Once they are fixed, the rod is clamped with the stand. Then the candle is lighted up by the lighter and is placed below one of the ends of the rod that is slightly distant from the first nail. As the heating process goes on, the rod becomes hot. Consequently, the nail which is closest to the candle falls down. After some time, the next nail, that is the second nail, also falls down. Similarly, the next 2 nails. Here we notice that heat transfer takes place from hot end of the rod through its different parts to the other end. This type of heat transfer is called conduction. There is no actual flow of the particles of the solid medium. Still, the heat transfer process takes place. Now we will perform an experiment on convection. It is a mode of heat transfer by actual movement of the particles of the fluid medium. It is possible only in fluids. To perform the experiment, we require a tweezer, stirrer, small amount of potassium permanganate, 2 beakers filled with normal water, 2 small glass containers, and some hot water. First we put some hot water in the small glass container. Then we add a pinch of potassium permanganate to it and stir it until it becomes fully dissolved. Now, with the help of the thread tied to the glass container, we put it inside the beaker filled with normal water. What do we observe? We observe that the hot water from the container starts moving upward. This type of heat transfer, in which actual movement of particle is involved, is called convection. Now we put some potassium permanganate in the glass container filled with normal water. When this container is dipped in a beaker filled with normal water, it is clearly seen that there is no movement of colored fluid. As the hot water is less dense and expands up, it is replaced by cold water. Again, this is heated up and the process goes on. So this type of entire process is called convection. An example of the natural convection is sea breeze and land breeze. Try to find out the reason why sea breeze takes place in daytime and land breeze takes place at the night. The mechanism of heat transfer which doesn't need any medium is called radiation. To perform the experiment, we require a 500-watt halogen bulb, a thermocouple. First, the thermocouple is connected by an adapter. We notice that the display of thermocouple indicates room temperature. Now we switch on the 500-watt halogen bulb. We hold the halogen bulb from some height and focus it on the board. After some time, we can feel the radiant energy coming from it. The air just below the bulb becomes hot and moves upward as the air becomes less dense. So the space just below the halogen bulb becomes partially vacuum. In order to verify the heat energy coming from the bulb, we put the sensor of the thermocouple below the halogen bulb. The temperature is increasing as indicated by thermocouple, and it reaches up to 75 degrees Celsius and also goes on. How this happens? Heat is being transferred from the halogen bulb to the bottom portion even when it is partially vacuum. This mode of heat transfer is called radiation. An example of the usage of heat transfer in our everyday life is thermos bottle or Dewar flask. It is used to minimize heat transfer between the contents of the bottle and outside. It consists of a double-walled glass vessel with the inner wall and outer wall coated with silver. Radiation from the inner wall is reflected back into the contents of the bottle. The outer wall reflects back any incoming radiation. The space between the inner wall and outer wall is evacuated to reduce conduction and convection loss, and the flask is supported on an insulator like cork. The device is therefore useful for preventing hot contents from getting cold, or alternatively to store cold contents.